what else is interesting and different about the two? So they do look quite similar, and compositionally they're not that different. There's one really striking difference between the two as well. Anybody?
Is it Mercury's core so much hotter?
It's a huge core, yeah. It's mostly core, which is interesting. So, and Mercury has this faint magnetic field too, which is quite interesting. I mean, if you take one thing away from this class, I think you're going to take that magnetism is a huge player in the party that we're examining. It seems to be at the heart of what makes this planet such a, I mean, well, we can't discount liquid water as well, but there's something really special about us having this great protective bubble. It's almost like a Star Wars force field that's shielding us from the nightmare that it would be otherwise. And so when we start talking about Venus today, we'll mostly talk about Venus today, but Venus is, in some sense, very, very similar to Earth, except for that one feature. I mean, there's a lot of differences, but in some sense, it seems like a lot of the differences could be boiled down to the fact that Venus doesn't have a magnetic field. And so we need to ask questions about why that is. I mean, why do we have this magnetic field is something that we're going to get a little bit closer to today as well. We talked a bit about the spinning forces of the Earth, which generate these eddies, something approximating a solenoid or an electromagnet, right? And we have this solid core which stabilizes it, and that's all well and good. But you look at something like Mercury, and the conventional explanation for Mercury's magnetic field is that it's being sloshed around. It has this eccentric orbit. It's a little bit more elliptical, right? And so it's sloshing as it goes past the sun each time, and that's keeping these currents going, which are able to perpetuate its magnetic field. And I think that there's something to that with the Earth as well, because it looks like the moon might play a role in that. And we're going to talk a bit more in depth about that today. There's some really interesting research lately that demonstrated some excess heat in the Earth that shouldn't really be there in terms of its presumed history and its cooling, or the rate of cooling that it should be experiencing. It's a bit warmer than it should be. And so why is that? Well, it seems like the moon might play a big role in that. So there's something really special about the Earth that's not just the Earth. It's not even just the Earth and the magnetic field. It's the Earth-Moon system that's really unique. The ratio of the size of our moon to our planet is completely anomalous in the solar system. There's no other system of bodies, there's no other, let's say, planet-moon system that's in any way approximate to the ratio of sizes that we have here. It's very, very unique. We have a huge moon for a pretty little planet. And so that doesn't seem to be insignificant. And you can obviously see the effects of this with the tides on the ocean, but you got to think something like that must be going on under our feet too, with all this molten stuff. And so I think that that's beginning to play an important role in the story of this magnetic field that is, of course, our complete savior with respect to all the cosmic forces that would otherwise be destroying us. And so when we go to investigate Venus today, it's going to be the most important thing to understand about Venus. I think the reason that we're so interested in it is because in some sense, geologically, it's so similar to Earth. And yet, it is so very inhospitable and such a really gnarly place to even try to visit with spacecraft. So let's try to keep Earth at the center of this picture as we talk about Venus, because there's this very popular wisdom in science, I would say almost since ever, which is something like our scientific theories are only as good as they are useful to us, which is a very difficult platform to argue with. I think it's not a totally complete picture because I think that there's a great deal of curiosity to feed in science. Like just wanting to know how things work seems to be a good end by itself. But generally speaking, we also need to contextualize what we're learning. Like, who cares? Why should we even care about Venus, right? And of course, the answer to that is because it can tell us a bit about our own home. And of course, when we're exploring space, we're generally interested in what does a new home look like. I really think that that's the teleological end. That's really what we're really interested in when it comes to space exploration. It's under the surface of every discussion. Okay, so that's the big picture. Today I'm going to actually retouch on the Venus mythology just because I think it's really fascinating, and it's not exactly astronomy per se, but the ancients would have disagreed because people have been staring at the stars for tens, maybe hundreds of thousands of years, and they weren't telling the story of rocks and geometric forces that were carving out their orbits, right? They were telling stories that were meaningful to their everyday life. And I think that the story of Venus is one of, well, it's definitely in the top 10 of most conserved stories across the globe. In other words, people on opposite sides of the ocean came up with really similar stories for what Venus meant to them as a culture. So I want to compare and contrast a few of those mythologies because I just think there's something so fundamentally human about it. There's something that this Venus does in the sky that captures something that happens inside of each one of us. And that's something we can't ignore. I think it's worth spending some time on. So after we do that, we'll check out Venus's geology, like I was saying, and try to make some sense of how it relates to the Earth. And if we get through all that today, we will start into Mars, because that's the next stop on the train. And then, I guess following that, we will be moving out into the big giant planets, which are pretty cool because they have, the giant planets, in some sense, in so much as we are able to talk about the sun and stars, the giant planets are a strange little missing link in between stars and planets. They're made of much of the same stuff as stars. They're organized in some way similarly. They're just not big enough to be stars. And so that's really interesting. They make, they fill in a gap for us. They also have incredible moons, the giant planets, and so we'll spend some time checking them out. I mean, there's even hope of finding primitive life forms on some of these moons. The moons, in some sense, have compositional aspects which resemble planets, right? Some of them are thought to have liquid water beneath their icy shells. And so there's a lot to look at there. Are they hot? Oh, yeah. They're hot from compression, though, right? Yeah, it's sort of like like a diesel engine or something, right? When you squeeze something, you warm it up. And so they have a lot of material, and it's under a great deal of gravitational compression. And so they're heated through this, it's called the Kelvin-Helmholtz mechanism. But it's basically, this is how they originally hoped that they would explain how stars are heated as well. And the problem with that, which we'll look at next semester more, is that if you heat a star that way, you can do it. You might be able to explain how it's so hot. Problem is it burns out in a matter of millions of years that way. And so the astronomers had to figure out a new way to heat the stars. And it was a real crisis all the way up until barely more than 100 years ago when they came up with the fusion idea, which is basically making new elements, which releases a little bit of energy. So, yes, they're quite toasty, and in fact, some of the giant planets that we see out in the solar system are really hot. I mean, really, really hot. Some of them, there's a fuzzy border between stars and some of these planets at some point. And in fact, they're finding with these new James Webb telescope, they're finding pairs of these Jupiter-like planets orbiting each other with no star whatsoever, which is really fascinating. So, just freely speculating, I think that the story of star formation is going to become much different than it was in the past, because generally speaking, we spent a good deal of time talking about the formation models for the solar system. And you got to think, we have the same formation model that we're wrestling with now that we came up with 300 years ago, before we could see any of these things, right? Before we could see pairs of Jupiters orbiting each other in the Orion Nebula, before we could see exoplanets and very baby exoplanet systems forming. So everything that we came up with to explain the way our solar system looked was based on our solar system. So that's a somewhat limited perspective. And it seems to me like there's a real crumbling line between stars and planets. And I think that that's going to play a huge role in understanding the formation of solar systems in general. Because I imagine that there's room for solar systems to be snatching up planets, right? That maybe were on their way to become stars at some point, and then they got into the system, right? If you look at one way to know how long something has been part of a system, I think, would be to look at how stable, how low, how stable its orbit is, how much angular inclination does its axis have, for instance. That's an interesting marker of stability. And some of these really old-looking bodies in our solar system, like our moon and like Mercury, they look, this is of course very superficial, but they look very old. They're crusty old rocks, basically, right? As opposed to something that looks fresher, like Jupiter or Venus, or not Venus, Jupiter or Saturn, right? They're these milky, liquidous bodies, right? These really old ones have almost perfect axial alignment with the sun, which is really interesting, and I think there's going to be tons to mine there in the future. I really, really think that this story is on the move, and why shouldn't it be? Right? I mean, like I keep saying, 200 years ago, we thought the Earth was 6,000 years old. Less than, back in the 20s or 30s, we thought that the galaxy that we live in was the entire universe. This is how rapidly our perception is changing about everything that we see. The further we can see, the more we see of things that look like us, and the better that informs our own story of what's happening here. So these things are really on the move, and I'm throwing a lot of these kind of crazy ideas out at you, not because necessarily they are in any way accepted in whole by the astronomical community, but because I see them as gaps that are opening up for development, which your generation, honestly, is going to be the ones to develop. And I doubt that any of you are going to go into professional astronomy, but if you did, these would be the topics that you would want to check out, because that's where the real fertile ground is going to be at, Yeah.
With us figuring out that we're not the only galaxy, have they decided if everything's rotating on a certain, from an exact point, or is that the mystery that's still...
If all the galaxies are rotating in a similar plane or something?
Pulling all of them in the same direction, or are they moving opposite ways?
Yeah, it's a huge topic. So are you going to be around next semester?
I was thinking about
All right, do it, because we'll tear that apart. Okay. There's a number of ways to look at that, and I'd have to crack open a huge can of worms to even break open the methodology for that. But actually, the way that the cosmos seems to be organized is very filamentary, and it's something like a spider web, actually, which is really interesting. They've started to look at the layout of these galaxies in mass, at cosmic distances, hundreds of thousands of light years separated. Honestly, I think there's something like 1 trillion light years between each one of these galaxies. Don't quote me on that. I have to check it out. It's an unimaginable distance. But even at those distances, the galaxies seem to be strung along on these strings, essentially. And they, of course, have these central jets of material that you can imagine somehow enmeshing with one another and kind of locking these things in place. So the greater superstructure of the astrophysical landscape seems to be something like a spider web, which is really fascinating. And I think there's really something to be understood about that, especially because all of our attempts to make sense of the invisible forces here that we're aware of, like gravity and light and electromagnetism, people don't really mess around much anymore with the material basis for those phenomena. This is actually, I'm writing a book right now with my wife about this, because it's really interesting how science just stopped caring about that question at some point. They came up with this idea of fields. And a field, it sounds like it's some sort of material actor, but the more you dig into it, you realize that a field is really just a set of vectors, right? It's essentially telling you how your measurement device is going to react in some given location, right? It's basically a quantity that varies with time or distance, location. So at some point, people stopped caring about what was the mediator of all of these invisible phenomena. They couldn't solve that problem, and so they just realized that, hey, we don't need to deal with that, because all we need to do is parameterize these things, and we can build incredible technologies. And they're right about that. They really, obviously, we have incredible electronics, and yet we only have essentially something like a wiring diagram of how these things really work at the atomic level. And so what I'm getting at is that I think that beautiful spider web that we see that the galaxies are organized in might tell us something about the way that our atoms are also organized. I think that there's something really, really intuitively informative about the landscape that we're seeing there. And of course, this web-like architecture seems like it's more than capable of maintaining tension, which is something that you can think about gravity as a kind of tension. Same with magnetic influences and so forth. So I think there's something really, really beautiful there that will appear. It's just a matter of whether people will even bother to care about that question ever again. I think they will, though. It seems to go in cycles. Again, it comes back to the question of what's the value of your scientific theory? Like, does thinking about the atoms in terms of their material basis give you anything? And I would argue that it gives you a better sense of what's happening, and it brings more people into the fold of the discussion, right? People who engineer tend to be highly mathematically oriented. But that's a really small portion of the population that can visualize things in quantities, right? Perhaps you've met someone like that, or maybe you happen to be one of those people. Probably not, because you'd be probably an engineering or science major if you were. But needless to say, I think being able to think of things in material terms is a much more intuitive way of looking at them, and it's probably a better way to work the imagination and bring more people into the discussion, which is probably highly productive for society in general. So that's a really interesting thing. We'll just keep coming back into that, because that's one of my pet topics, and so I don't know how we got into this. But let's talk about Venus a little bit. Yeah, please finish it off. Okay, so I told you that Venus seems to have been the most obsessed over. They would have thought of it as a star, the ancients, but it's the brightest body after the sun and the moon, right? So this makes a lot of sense. You guys, have you all seen Venus? I'm sure you have, whether you realized it or not. It is, if you go outside and you look up on pretty much any given night, except for a few days every, year and a half or so when it disappears completely, you'll either see Venus early in the morning, you'll see it late at night. It is very, very bright, and the ancestors were all, of course, very aware of this. And of course, it's one of those wandering stars, right? So if you're an ancient person looking up at the sky, you pretty much start to, it's just like your backyard at some point. You know where everything is. You know the hose is over there and the cars are parked over here. Well, they were familiar with the sky in the same sense, and there's a few of these stars that didn't seem to be in the same place every night, and they underwent their own patterns of motion. These were the wandering stars. We call them planets today. And so Venus was the brightest and most noticeable of all these wandering stars. And as we'll see, I'm going to pick this apart a little bit tighter, but Venus does this really, really strange thing compared to a lot of other stars. Well, I'm calling them stars, and let's just roll with that for now. But of course, the ancients thought of them as stars. They're orbs in the sky, right? And honestly, as we're talking about, once we get to the giant planets, I think that the line between planet and star is a sort of crumbling line at some point. And so I don't think that's totally unreasonable to call these things stars, because the word stars is sort of arbitrary categorization of, we define a star as when it can fuse hydrogen. But I think getting too attached to these delineations can drive you into some darkness too. I guess what I mean by that is that, think of a brown dwarf, which is just basically almost a star, right? It doesn't quite have enough hydrogen to be heavy enough to fuse hydrogen. But at some point, the line between a brown dwarf and a star is a single atom. At some point, there's one atom that if that star had it, it would be heavy enough to start squishing. There's a breaking point, right? But by the same logic, there's a star that if it loses one atom, now it's a brown dwarf all of a sudden. And so that line between planet and star just seems to be a really, really nebulous border. And a lot of our astrophysical theory doesn't take into account the fact that, wait a second, maybe some objects are stars for a minute, and then maybe they're a planet the next minute. Maybe there's actually transitions both directions, right? And so I think that line between planet and a giant planet, let's say, and star is a reasonable boundary to question, especially when we think about the long-term evolution of these bodies. Like, what were they at one point? It's a very interesting question. And one that the future, no doubt, will be obsessed with. So, yeah, these are the these are the apparent magnitudes. Remember, the magnitude system was set up to originally only go to 0, right? Because they were looking at faraway stars. And they had to go into the negatives to account for some of these really bright planets. And our own sun, for instance, minus almost 27. Venus is minus 4. It's not that much less bright than the moon, for instance, on a full moon night. So yeah, the ancients were very much aware of this one. It was very easy to see. Some of the earliest accounts of this, I mean, pretty much most of our Western sciences can be traced back to Mesopotamia, the cradle of civilization. And the Mesopotamian astronomers, they named Venus after one of their gods, Ishtar. And Ishtar had these horns, which is a central feature of the Sumerian religion. And some people speculate that the horns were in some sense reflective of the crescent shape of Venus, so that they had some sense. Remember, that idea that Venus has a crescent is informative of the fact that it has phases, which tells us that it's moving around the sun. And so whether or not they realized that the thing was orbiting the sun is not entirely clear. But if they were, it was lost for 1,000 years or so, several thousand years, all the way up to Galileo's telescope moment. So that's kind of interesting. The fact that all of our knowledge, all of our Western knowledge can be traced back to this place is really, really strange if you think about what's happened to that place in recent years, right? It's so Mesopotamia, let's say Babylon. Does anybody know where Babylon is in modern day?
Syria?
It's basically in Baghdad. It's basically in the most, destroyed place on the planet right now, which is very, very, I think it's just like a tragedy of unimaginable proportions if you really start to contemplate what we've done to that place, which is essentially the foundation of all of our Western knowledge, and the foundation, it's called the cradle of civilization, right? And we've essentially bombed it into oblivion and replaced it with a really crummy government that wasn't able to hold up its posts. And now it's been overrun by radical extremists, and it's just a real mess. And I just think that that's just an abomination. All right, so anyways, what's really interesting about Venus, and this is something that the ancients picked up on, and this is, I think, why, in some sense, a very similar story is told all around the globe, from Mesopotamia to the Far East to the ancient Mayans and Mesoamericans. They all tell this story of the descent into the underworld. So let's look at exactly why this happens. So here's the thing. When you're looking at Venus, it appears in the morning for about 263 days, and then it goes behind the sun for about 50 days, and then it's in the evening for 263 more days, and then it's in front of the sun for about 8 days. So there's this natural idea that it's there in one form, and many of these cultures actually treated it as two different stars. They gave it a different name in the morning than when it appeared in the evening. But each one, during this transformation from morning star to evening star, it's gone. It's disappeared down below somewhere, right? Out of view. They would have thought of it as disappearing underneath them into the underworld, right? And there's something very powerful about this. why didn't they just tell the story of a star disappearing or something, right? There's something about this transformation that appears over and over again. And I want to talk about a few examples of that before we try to tie them all together into something that is fundamentally human. So this is the Sumerian goddess Inanna, which is also, Ishtar was what it was called. She was called by the Akkadians and Babylonians, who are a little bit later rendition of the Sumerian culture. And she's interesting. So she represents. She has this dualistic aspects to her. She's the goddess of love, but she's also the goddess of war. And you might think that's really strange. Like, why would one god be the god of love and war? And I don't think you have to think too hard about that if you've ever been in a relationship before, right? And I don't think that that's accidental either, nor do I think it's a bad thing. I mean, I think that the kind of, if I look back at all the relationships I've been in, I think in some sense the ones that were doomed to fail the most were the ones that didn't have that aspect of war in them enough, honestly. Because you think about it, you don't want to spend your life with somebody for the next 50 years that's going to just nod their head at every stupid idea that comes out of your head, right? You really want somebody to tango with, somebody to wrestle with, right? I mean, and if it gets, this actually proves out in the psychological literature to some extent too. It's something like if you have, let's say for every 10 positive interactions you have only, let's say, one negative interaction. Well, that's not enough. Those marriages don't seem to be sustainable. But if you have too many, let's say you have 10 negative reactions for every 10 positive reactions, that seems to be too much. So there's this interesting balance point between love and war that's essential to every single human relationship. I don't think it's just limited to romantic relationships either. It's kind of something you want from your friends too, right? I mean, especially if you're successful, right? Especially if you find yourself being kind of at the top of your friend circle, whatever that means, right? Or let's say in a workplace in the future, wherever you guys end up, if you're at the top of some hierarchy of competence, right? The worst thing that you can do is surround yourself with a bunch of yes men, right? It's absolutely devastating. If you find yourself surrounded by people who aren't capable of pushing back against you, it's lights out for you. You will be depressed, you will be anxious, you will have no compass. And so I think that celebrating this attraction and repulsion in one entity was actually a really brilliant insight. And of course, all these people are drawing these mythologies from their common experience of over hundreds of thousands of years of sorting out being a human and what it meant to be a human. And obviously, being a human is a terribly complicated endeavor. And in some sense, we spend our whole lives figuring out how to do it just in time to die. So there's really something profound about that. And it seems like the Sumerians captured that. And all these other cultures that we're going to talk about, they also pick up on that to some extent. Now, there's also this theme of transformation, too, which starts to appear. So the Sumerians have this myth that accompanies their Venus goddess, Inanna. And it's something like, it's some sort of descent into the underworld followed by this resurrection. And we'll see that over and over again. Let's look at some other examples of it. What's interesting is that later on, the descendants, in some sense, culturally, of the Sumerians could be the next earliest people that are like a real presence in the area are the Canaanite culture. Now, the Canaanites don't get a lot of play well, I can tell you why they don't get a lot of play in a minute, but we don't really think of them as much. Usually when you guys, I don't know what humanities courses you're taking, but you'll generally read a lot of the Greeks next, right? That's mainly where we go to after the Sumerians. Maybe you'll get some Persian stuff, but generally it's the Greeks, right? But this leaves out a huge chunk of history, which was the Canaanite culture. The reason that we don't really hear much about the Canaanite culture is because their descendants, which were called the Carthaginians, were completely eradicated from the earth by the Romans. There's this very interesting series of wars that went down between this Punic Empire and the Romans and the Punics in Carthage, which was right across the Mediterranean Ocean from Rome. They were always kind of picking at Rome and bothering them. And at some point, famously, Hannibal sent this huge army around the Iberian Peninsula through Spain and over the Pyrenees Mountains. He literally drove elephants over the freaking mountains and attacked Rome. And so after several generations of this going on, Rome decided they'd had enough, and they actually mustered all of their energies to go and sack Carthage. They burned Carthage to the ground, they salted the earth, and they destroyed all of their history. All of their religion was outlawed, and we essentially lost the tracks of this incredibly powerful civilization that dates back to the time essentially just after the Sumerians. Now, the reason I bring all this up is because some interesting transitions happened in that period. So, and another part of this, by the way, so the precursors to the Greeks are often considered the Minoan cultures. The Minoans seem to have been, in some sense, metropolitanly aligned with the Canaanite culture. They had very similar artwork. They probably had similar trade networks. And in some sense, the Canaanites were the merchant class and perhaps the Minoans were more like the ruling class of that same civilization. And an interesting transition happens here because, as we know, the Minoan culture was a deeply matriarchal culture, right? They seem to have been, in some sense, ruled by women, which is very, very unique in history. But this transition happens because when we look at the Sumerian story of Venus, it's a female goddess that embodies Venus. Well, what happens in the Canaanite culture is that same story appears and it gets transmuted into a situation where the Venus deity becomes a male. And that's the principal difference between the two stories. You still have this descent into the underworld, but all of a sudden you have this you have the same character introduced as a male deity. This is really interesting. So the story that the Canaanites tell a bit later here is that some deity, they call this one deity, say represented by, say, the morning star, as this god called Atar. And Atar attempts to basically dethrone the overarching god, which they called Baal, and then fails at doing that and is banished into the underworld. And then there's this resurrection that occurs after that. So it's a very similar story, but there are these masculine deities that appear. By the way, Baal is later introduced as El in the Hebrew Bible. And El is a really interesting term because that is the basis for the articles that we use in say, Spanish language, right? If you say El in front of this, like, I don't know, El queso or something, I don't know, right? So this word El is in some sense deifying our nouns, right? And we have the same thing in English because we put the in front of all of our nouns, right? The word the has its roots in thea, right? Thea, which is God. So in some sense, we're deifying our nouns based on this super ancient tradition, which I think is just mind-numbingly fascinating, that we ascribe something. Yes?
I'm just curious, who is Baal?
Baal was the chief god of the Canaanites. Okay. Yeah, which by the way, I guess I made a leap there that wasn't entirely clear. The Hebrews were descendants of the Canaanites. And so all of the modern Judeo-Christian traditions derive directly back to the Canaanites. Yeah, you probably heard it in the Bible. Yeah. So the word Canaan appears many times in the Bible. And there's this whole interesting mythology in the Bible which we just have no time for.
Do you know what Baal was the god of?
Baal was just the supreme deity. Okay. So it was a sort of pantheistic religion, but there was still a hierarchy of gods. So there's somebody at the top still. And in some sense, what the Hebrews did for the first time was to unify all of those gods under one idea. And they took that chief deity, Baal, and made this deity that subsumed all of the other deities into this god called El, which becomes Elohim in the Hebrew Bible. And then eventually that becomes Yahweh and God as we know it. In the Christian tradition, it's just God, right? Actually, if it's the way it's written in the Bible, it's supposed to be this sort of unpronounceable word. But and actually, Yah was one of the sub-gods in the Canaanite tradition. So he was a sort of minor storm god underneath the bigger gods. So I don't know. I think that it's really valuable to trace back the roots of these things. I mean, it's so crazy that I've probably used the word "the" 100 times in this talk already, and we don't even think about what the heck that word means. Like, why do we even do that? Why do we deify these words? There's really something interesting there to contemplate. I mean, you could just get lost for hours thinking about why we do that. Like, why is it important for us to deify nouns? Why do we give them that supremacy? And there's really, really something profound about that. I mean, there's something that humans do, in some sense, by naming things that makes them real. It's like there's been several different philosophers, modern philosophers, some of the greatest philosophers who have really started to realize that the way that humans interact with the physical universe is not so much in terms of like the material bodies themselves, but in terms of what they represent, the meaning that they have. And by giving something a name, you bestow it with this kind of meaning. And you see this appear in the Hebrew Bible, the Christian Bible too. Like the first book of Genesis talks about how Adam goes around giving names to things. And you think, wow, that's a really weird thing to include in a myth like this. Why would they even bother with this? And I think there's something really profound about that, because that's probably one of the first things humans did was start naming things, right? Because by naming things, you give them utility. You mark out exactly what they're good for. It's a chair not because of how it's arranged materially necessarily. It's a chair because of how I can use it. And all of that is contained in the word chair. And by virtue of the fact that I'm giving it all of those properties, there's something almost divine about it. And I think that's why we have the articles in front of the words, to represent how important and vital and almost, I don't know a better word than divine, but let's say cosmically important a particular noun is. It's not just chair, right? Although the Russians do that, which makes it very difficult for Russians to speak English because they don't have articles. But in the West, right, and Russia's a kind of interesting place in terms of their history of rebelling against the theocracies of the West and so forth. But yeah, in the West, we deify our nouns, right? We take them very seriously. We bestow them with this cosmic significance. And I don't think that that's an accident. I think there's something really deeply important to that. So the Canaanites take this tradition, they masculinize it to some extent, and carry it forward. Now that goes on, right, into, you start to see, in some sense, the Venus takes on a little more of a sinister role as we move down through the mythological tradition. So if we follow the Canaanite tradition down into the Hebrew Bible, we see the appearance of the discussion of Venus being this idea of a fallen angel, which is really interesting, because by the time that the Christian Bible appears, this fallen angel is essentially associated with the devil, with Lucifer, which is really interesting. The morning star, exactly, which of course descends into the underworld, right? This is the fallen angel, which dwells forever in the fiery pits of hell and stuff, essentially for trying to dethrone the supreme deity, right? This is an old story. This isn't something that the Christians came up with. This goes way back, I would say, all the way to the Sumerians, and God only knows who they got it from. So it's an old story. And not only is it an old story, it's not just that these people weren't creative enough to come up with their own story. It seems to be a foundational story. It seems to be a story that happens in real life that we have to tell. The Mayans, we'll see in a second, came up with the same story, okay? They had no contact with the Hebrews or the Canaanites or the Sumerians, but they come up with the same story on the other side of the world. Why is that? It speaks to something deeply significant about that story in that it plays out in all of our lives all the time. Look, if you haven't had a descent into the underworld yourself at this point in your life, you absolutely have that to look forward to at some point. It definitely happens to everybody all the time. I mean, it happens on the smallest level, right? It can happen just because you get in trouble, you get pulled over, you get anything bad happens to you. It's a very similar experience, right? Where you're dethroned and you have to spend this time in chaos in order to rebuild yourself and come back out on the other side. And people just seem to have realized this as a fundamental part of being a human. And so that's where we're at. That's where all of these different cultures are at. That's where they're coming from. All right. The Egyptians also, I mean, no doubt they have a very similar story. Their myth, their association is with Osiris. And Osiris is kind of interesting because Osiris gets killed by his brother Set, and who wants his throne, right? Very similar motif here, dethrones. So Set chops up Osiris's body. Osiris's wife finds the little body parts and stitches them back together so that she can become impregnated and gives birth to Horus. And Horus is born after, in a resurrection event, right? Because Osiris is now put back together by his wife, and the two, Horus and Osiris, then essentially rule Egypt together, hand in hand. So there's this same transformation event. The deity is destroyed because he tries to essentially, challenge, let's say, the cosmic order. It doesn't work out for him. He's destroyed. This happens to you. Like if you try to tell a lie, for instance, right, and you get caught for it. It's like that's happened to every one of us, I'm sure. What happens? Well, it's bad news, and you have to put yourself back together, and you have to heal all of these relationships in order to progress forward. It's the same thing that's happening here in these stories. And so the Egyptians obviously captured that in their own way. The Indians on the subcontinent, they had the same story going on themselves. Their deity was called Shukra. And Shukra is really interesting because Shukra possesses this magical ability to essentially raise the dead back to life, right? So the same story, the same resurrection story. You can't let go of it. There's something about dying this little death all of the time as a human being. And I think there's really something to that, in that you need to be able to let little pieces of yourself go in order to move forward. I mean, it's like the central tenet even of the Christian Bible, right? And you see the same thing in Islam. It's like, what do? What is the central idea? It's like, well, you forgive people, or you ask for forgiveness in order to move on. What does it mean to be forgiven? Well, it's like you're something new. You're not that old person who did that bad thing before. You've been sort of reborn in this new form that's capable and worthy of trust again, right? It's just, I think, absolutely, like, beyond the ability to have language and self-awareness. This is probably one of the first crises that humans encountered. Because as soon as you have the ability to represent ideas in words and interact with people, guess what? You have the ability to lie about things. And that's a real nightmare for human beings in general. Because you don't know who you can trust all of a sudden. I mean, when you don't have language, it's pretty easy to tell who you can trust. It's like, well, these are the people you were born with, It's like, that one guy, he's like a little ornery or whatever. But when people can represent themselves in words and in ideas, you're in a whole new landscape of deception. And of course, people can bear a whole great deal of trauma, right? I mean, people can bounce back from terrible violence and rape. They can bounce back from seeing incredible slaughters, genocides, and the Holocaust. But you know what people don't seem to be able to bounce back from? Being betrayed by somebody. It will absolutely devastate somebody's psychology. It's like, I don't know if any of you guys have experienced betrayal in your lives. Like, I certainly have in mine. It takes years and years and years to be able to trust people again. It's like, when you realize that somebody's not who you thought they were, it's like, good luck. Good luck trying to find somebody again that you can look at without thinking, well, maybe that person's not what I'm thinking they are, right? And that's just absolutely devastating to your interactions with people, with all people. It's really, really scary. And so the concept of forgiveness is important. The concept of being able to be reborn as somebody new is absolutely central, and finding ways to navigate that what would you say, that gauntlet seems to have been a central purpose for the religious and mythological stories that people were telling, because finding your way through that crisis is, in some sense, really what we all have to do, not only on a daily basis, but over the course of our lives. So, yeah. Islam also talks about this. They also have a very similar story. Now, by the time, Islam's is a much later tradition, much later even than Christianity and the Hebrew tradition that Christianity springs from. So Islam didn't really appear in full force until darn near 1,000 years after Christianity. Let's say 700 AD, something like that. And by the time of Islam, they had begun again to identify Venus as this beautiful woman. But there's this story that's told in the Quran of these two angels that descend to earth, and they're sort of seduced by this deity associated with, it's really an angel, I guess, associated with Venus named Zohra. And Zohra sort of corrupts them into committing all of these treacheries like murder and adultery and just getting wasted. And Zohra eventually saves them, though, in the end of the day. So she's in some sense the corrupter, but she also gives them the magic word to get back to heaven at the end of the day. So there's, again, this resurrection story that appears. So where else do we see it? I talked about the Mayans already. The Mayan story is generally associated with the god Kukulkan, who's also known in other parts as Quetzalcoatl. And it's a very similar descent into the underworld. Now, the Mayans and the Aztecs and the Mesoamericans, Venus was the most important body in the sky to them. In fact, they based their calendars more closely around Venus than around the sun and the moon. That's how important it was. And I'm not sure why that was, except for the fact that maybe this descent into the underworld played a more central role in their cosmology. It really was this story that I keep circling around, right? This rebirth business, this betrayal, this descent into the underworld was somehow much more important to them than any stories that they could find to tell about the yearly cycle with the sun and the moon and the harvest and timekeeping. That seems to have, in some sense, played a greater role in the West, particularly with the development of large-scale agriculture and so forth. Although they had agriculture in Mesoamerica as well, it doesn't seem to have been quite as wide scale. So, yeah, Mesoamericans took this myth absolutely, completely at the basis of their whole cosmology. And yeah, I'm not going to have time to go into the depth of that, but it's a parallel story. It's very much one of a hero journeying into the underworld and being resurrected. And so this is just absolutely nuts. You see it also in the Aboriginals, right? This is the Australian Aboriginal cultures. They have a very similar story with Venus spirits attempting to ascend back from the world below, which they call Minchapu. I just really hope that I can impress upon you that this is not a game of telephone where these cultures are telling a story from one person to the next. This is almost certainly, these ideas almost certainly appear after the birth of language in all of these different places, right? It's almost certainly happening because people are trying to reiterate some foundational experience and make some congruence with it in the stories that play out in the sky for themselves. Remember, they didn't have novels, they didn't have Netflix, they didn't have Twitter. They had the sky. That was all they had to tell stories by. And so it makes a lot of sense that they're going to tell similar stories. You know, it seems like people are sort of interested in the same things even today. Like, do you think that do people in China have fundamentally different movies than people in the West? I mean, maybe a little bit, like the names and places change, but the stories that we tell are basically the same, right? We're all humans. We all suffer the same crises from day to day. And so our stories tend to be pretty much the same. And I think that's really what we're looking at here. So transformation seems to be the fundamental human project. I mean, if you want to talk about, what's your job? Like a lot of you go to, you guys are all, for the most part, very young, just starting off your journey into the land of adulthood and dealing with the world face on in terms of making your own way. And like, what better way to conceive of that process than as a transformative journey? That's what you're doing. You're taking yourself from being a child that can hardly feed itself into someone who's capable of having children and capable of taking care of others. I mean, it is a transformative experience being a human being. Best case scenario, you find yourself a real masterpiece by the end of your life compared to where you started. I mean, hopefully you can already look back at your teenage self and be like, wow, I've come a long way since then. But hopefully it will only accelerate. And so, anyways, Venus seems to be at the heart of this transformative story. Everybody seems to have used Venus to tell that story across the ages, and it's not insignificant. It is, in some sense, the fundamental human story. Anybody have any thoughts or questions on that before we get back to the rocks?
It almost sounds like language came from Venus.
Yeah, I spend a lot of time contemplating the order of events. The order of events, like the naming of things, which came first, right? Were people experiencing these stories in some sense alinguistically? Like, were these ideas playing out? Were they watching the stars at night before they even had language and the ability to string thoughts together in a coherent form? Were they seeing, like, do animals, let's say other primates that don't have language in the conventional human sense, do they experience congruence with the sky when they stare at it all night long? Do they see their own inner lives? Do they see it reflecting their inner lives? I mean, God knows. I have no idea. But it's very difficult to say when language appeared on the planet too, because the best we would have was writing, and that obviously seems to have come much, 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 much later than language. Some animals have some rudimentary, you could call it a proto-language of some sort. There's different sounds. For instance, apes, they'll make this one particular noise when there's a snake in the room. That's one of the earliest, and actually what's really interesting is that noise, they do these terribly invasive studies with these apes, right? And they'll look at the parts of their brains that light up when they see something threatening like a snake. And it turns out to be the same region of the brain that people light up when they curse, right? So if somebody is like, something bad happens, like I spill my coffee and I'm like, damn it. Like, that's the same part of my brain that lights up in the chimp's brain when it sees a snake. There's an expletive that comes out, which is sort of the announcement of danger to the tribe, right? To the troop, I guess, of chimps. So there's something conservative about that. So it seems like the roots of language appear long before the ability to actually name things, which I think is, naming of things seems to be the prototypical human linguistic aspect. The ability to actually take the function of, and you can sort of see that in the chimps with the expletive of the snake. It's like, it's not just an animal to them, it's an animal that means something, and it means that it's dangerous, right? And so there is a little hint of the naming of things with that sound that the chimps make. It's a proto-language, but it's not a fully formed language because, of course, we have the ability to name anything we want. That's just absolutely incredible, and I think that's what makes us such powerful animals, is that we can do that. I can come up with, actually, one of my favorite things to do is to come up with new words, right? I think Shakespeare came up with something like 50,000 new words in his lexicon, right? So how do words come into being? Well, you identify something that doesn't have a word for it, but it should, and you just start using it, which is pretty cool. I mean, I encourage you all to do that, because I think that's how we move forward, and that's how we understand the world better, because new things, they've appeared in our lifetime. Lots of words have appeared. I mean, the internet, right? Lots of words that are just common. Googling things, right? That's a new one. Well, not new to you guys, but sort of new in my lifetime. But there's common words that just creep out, right? They're needed to be there. There's some activity, process. There's some useful interaction in the world that doesn't have a sound associated with it, and we give it that, and that makes it a meaningful interaction. It gives us power as human beings to wield that process all of a sudden. So yeah, there's something just absolutely magnificent about our ability to name things, and I think that's why it appears centrally, and I think that's why it's in the first, few lines of the Bible, right? It's like, it's one of the first things that happens with these human beings in that story. And I think the ancestors were deeply aware. And of course the Bible, the word Bible just means library, right? So for the people from the Canaanite Hebrew tradition, this was just their collection of works, right? This was sort of their mythological collection. And why is that at the front of their library? It's like, hey, this is important. This is how things went down a long time ago. This is not in any literal sense, right? I don't think that the ancient people were very literal people. Like they're seeing deities in the sky and stuff. These are all metaphors to them. And I think if we treat them as if they were being literal, then we end up thinking that they were superstitious idiots. But they weren't at all. They were very, very symbolic. They were very, very aware that the fundamental important things in life are not the physical actors that we're going to return to in just a second. The fundamental important pieces of the world are the processes and interactions. One of the most famous modern physicists and mathematicians, Alfred North Whitehead, developed this whole metaphysics in the 1920s, which turns out to be extremely important to modern philosophy, where he basically tried to say, hey, I think we're going about physics all wrong because explaining the world in terms of material actors seems to be of limited use. And if a scientific theory is to be gauged by its utility, maybe we should revert to thinking about things in terms of processes. And he came up with this whole thing called process metaphysics, right? And process physics, which is really just looking at systems and their interactions and delineating them by their meaning as opposed to by their surfaces, which is really what physics in the material sense means today, and where we're headed back to when we talk about Venus and when we travel throughout their solar system. I mean, the reason that I'm even talking about this stuff is because I think it can be terribly boring to just think about the material processes at play in the solar system. I think there's more to it than that, fundamentally, because there's more to our human experience, much more to, and I'd say fundamental to our human experience, that we engage with things in terms of their utility, what they mean to us. The chair is not a chair because of the things that it's made out of. In fact, this is a chair, that's a chair, this is a chair. They're all made out of different things. They're not even shaped the same, but we call them chairs, right? This is something really, really fundamental to existing in this universe for us, is what things mean to us. And so, obviously, the ancients spent a great deal of effort on what the stars meant to them. And they didn't do it because they were idiots, right? It's just so easy for modern astronomers and modern people with our incredible technologies to look back at these ancient people and think they were sort of primitive cave people. But they weren't at all. They were extremely intelligent, and they were just obsessed with a very different way at looking at the world than we are today. They were not obsessed in the same sense with material interactions so much as material interactions, the actual processes that were at play and that underpinned everything in our daily lives. And to be perfectly honest, we could probably use a little more of that in our world today, right? There's, I don't know if you guys have heard this term crisis of meaning in modern society, right? People have more, in some sense, materially, we have more than we've ever had in the world, right? Nobody's starving to death. That's completely brand new. In the 1800s, something like 90% of the population was fighting to get their daily bread every day. Today, it's completely inverted. It's like less than 10% of the world population is in that position. We have, what's our biggest health problem in America right now? Obesity, right? Who would have ever thought that would be a problem 200 years ago? It's like this material want is not there anymore, but there's something about having obsessed over the material conditions of existence that has been solved in modern times at the cost of a lot of these metaphysical realizations that the ancestors were more obsessed with. And so that's why I'm wasting, not wasting, but I'm taking pretty much this entire lecture to talk about, because this has a tendency to get lost. And I want you to understand that it's not incompatible with science in any sense. It's often this hard line, this hard wall that's drawn between science and metaphysics. And I don't think they're incompatible, and I don't think that we can even keep them separated if we want to. And we'll see this much, much more next semester when we start to talk at the end of the term about cosmology, and we talk about the Big Bang. And and we start to see how these mythologies have crept back into the science. We can't really get them out of our head. It's not really possible to view the world in terms of things that are meaningless, right? In terms of just abstract objects crashing into one another. So while there certainly is a material basis for existence, right? I'm not going to be able to just, float off of this desk right now just because I want to. There's certainly material cause and effect. It doesn't seem to be the whole story. And nor is it perhaps even most of the story. And that's what I'm trying to get at here. And that's why I'm taking the time to talk about these mythologies. Because I think that these traditional ancient peoples were really, really onto something. I think they really, really made some good moves in terms of centering these stories at the height of their investigation of the cosmos. They're really, really important things to have a grip on. And if you don't have those roadmaps, if you wander into your 20s, it can be a very, very chaotic time period if you have to discover all of these truths for yourself without anybody having given you something like a GPS of what's going to happen. And so the ancients were very, very concerned with preparing their people. I mean, you got to think, by the way, these people didn't live very long, right? If you were made it to 40, right? I'm 40. If you make it to 40, it's like you're an old man at that point. It's like you've really won the lottery in some sense. So you've got to figure out how to live quick. You're going to have a family by the time that you're 17 or 18 probably. You might have 10 kids by the time you're 30, right? So you don't have time to just putter around in your 20s and stumble into all of these landmines that we all had to go through, right? There wasn't a time for that. So I think in some sense these mythologies sped up the transmission of knowledge to these people in a way that we don't have today. So, all right, last 15 minutes, let's get back to the rocks. Does anybody have any more points or revelations or questions about these topics? There's so much more to be investigated about this. I mean, if you like this kind of stuff, there's plenty of cool YouTube channels that go into the deep mythology of the ancients, and there's just so much to be learned about your own life through studying these things. All right, back to material reality. So there's been something like 50 spacecraft that have been sent to Venus since the dawn. Yeah.
I think the slideshow fell asleep.
Oh, no. Interesting. Maybe it's this. Let's try this. The first time we got anywhere close was this Mariner 2 flyby. The Soviet Union, of course, was the first to actually put a probe down on this thing. And I think I mentioned this last time. That probe was only able to sustain communications for about 23 minutes before it completely imploded. The pressures are unimaginable, 100 times the atmosphere that we experience here. And honestly, as we talked about when we were doing our own atmosphere, we're under a good deal of pressure right now. The good news is it's equalized. And of course, the pressure in these vessels was not equalized, and so they were destroyed very quickly. The US Pioneer orbited Venus in the 70s and developed these really cool radar maps, which gave us some sense of topology. So, Venus is covered in these really thick clouds. And the really good news about radio waves is that they're able to be relayed through clouds, right? They do a pretty good job with clouds. Not perfect. You may have experienced some drop in reception on your cell phone on a really stormy, cloudy day. Water does absorb in the radio bands pretty well, so that becomes a problem. But at any rate, this radar was able to penetrate, and I think something like, almost, I don't want to say all, but most of the information we have about Venus comes from this one orbiter probe. And we're on our way back there now, but this kind of starts to get into this realm where a lot of the stories that we're able to tell concern increasingly less information about these other worlds. So we have, we've definitely, we're going to have more to say about Mars materially because we've been to Mars and we can hang out on Mars, at least our robots can, and we can study it in much greater detail than Venus. We can actually see Mars too, right? It doesn't have this cloudy system, so it's much easier to study from, let's say, satellite-based telescopes. But Venus is a real nightmare because the only way to really see it is to dive down through these clouds, which are, of course, terribly toxic and corroding. There's sulfuric acid and pressures and heat, right? Remember, Venus turns extremely slowly. I think I mentioned this last time. its day is longer than its year, right? So it's barely turning, and so that means one side of it is just scorching hot at all times. And it's turning, so it does cool off, and the dark side is, of course, extremely cold. And so it's a real problem in terms of how we would even go about exploring it in the long term. And there's a couple of solutions we'll talk about. What we do know, this is a nice topographical, I think is the right word, topographical map of Venus. About 75% of its surface seems to consist of these lowland lava plains, which are very similar to the Maria that we talked about on the moon. These are, they're these same basic basaltic ocean basin type things. It does seem like there is some rising of hot material, so there is some convection. And traditionally, when we talked about the motion of these currents, these magnetic currents, electromagnetic currents that give us our magnetic field, the textbook explanation is it has a lot to do with convection cycles and so forth. That's a bit puzzling because Venus also seems to have plenty of convection, no magnetic field, however, which is very strange. So, well, that might have something to do with it. That's a really good point. Maybe it has plenty of convection, but the organization of that convection isn't toroidal in the same sense that we would expect from a solenoid in order to give us a magnetic field. Maybe that's all it is. Actually, and it seems like, so Venus is spinning the wrong way too, which is very, very, very bizarre. And there's not really any agreed upon reason for why that is. Of course, and it seems to be starting to get in line with everybody else. So in other words, its rotation is the wrong way, but it's slowing down, which kind of leads one to believe that at some point it will start spinning the proper direction, which is, the same direction as all of the other planets in the direction of their orbit and so forth, which would make a lot of sense. But it almost it's spoken of maybe the thing having a really interesting history that's different from everybody else, In some sense, maybe it's a newcomer to the party. Maybe it's new to its position in the solar system. I think some of the most popular ideas are that it was, bumped into by some other protoplanet during its formation. Again, we're working off this kind of antiquated idea that all of the planets formed right where they were in the first place, which I am increasingly suspicious of being a valid way of looking at these things. What I mentioned this before, when we look at those exoplanets, one type of exoplanet that we see consistently is this exoplanet with a really thick atmosphere, right? Kind of like Venus, but even way thicker, right? And it's getting its atmosphere cooked off by the sun. It's just getting blasted away, right? And what's really interesting is you can kind of imagine, well, what would that look like, right? What would a planet look like after 1 billion years of getting its atmosphere blasted away? Well, it might look a lot like this, actually, right? So maybe Venus has a much different, deeper history than we can even imagine right now. And of course, traditional empirical science being a very, very conservative discipline that's limited to explaining things based on what we can see right now, it's going to be kind of impossible to ever tell a definitive story about the history of this along the lines of what I'm saying. But it does seem to have a different history than everybody else, if for no other reason than things going in the wrong direction, right? So, I can't tell you, nobody can tell you anything definitive about that, and I doubt they'll ever be able to, but you have to sort of start to make your own picture up in your mind of what you think could be happening based on the evidence, because no one's going to tell you that story. It's just impossible. And the only story they're going to tell you is something extremely conservative that doesn't make sense either. So that's the fun part about astronomy, is particularly planetary astronomy. But in astronomy in general, it's like the amount of information we have is so thin compared to what we need to be able to tell a definitive story of what happened, It's like, it's like you walk into a crime scene and there's just some bodies and you don't know anything about what happened. You try to make a story up and you try to convince the jury of it at the end of the day, but, innocent people get convicted all the time. So, all right, 5 more minutes here. So there is evidence of convection, like I was saying. There's these these little rifts where it's thought that these are something approximating the cracks in our own crust, right, where there's upwelling of magma. There's these are volcanic, what would you call them? I don't know. What is a pre-volcano called? A little nodule, right? These are all thought to represent places where convection in the mantle is transporting the interior heat to the surface. And so plenty of convection. Maybe the rotation dynamics aren't appropriate for the magnetism to appear. Another thing I guess we haven't gotten to either is that the interior, the rocks, right? Let's say the mineral composition is not so different from Earth. I think we'll have a chance to look at that in a second. This is a picture of Venus from one of those early landers. What do we see here? The craters are quite interesting on Venus too. So the craters are there's very few. And the craters seem to, remember we can use craters when we want to date the surface of a body. And in this sense, the surface of Venus appears to be only on the order of a few hundreds of millions of years old. And so it seems like the surface is being constantly remodeled, much like the surface of the Earth. Remember, our ocean floors are also only a couple 100 million years old too, which is really, really interesting. So there's this constant remodeling of the surface going on as those volcanoes spew out new rock, right? New magma, new basalt that's able to cover up the traces of anything that came before. Here's some more of those molten material. It's interesting, they call these convection currents that they see, the evidence of these convection currents on the surface, they call these tectonic processes, which is interesting because tectonic has gone, in my lifetime, from meaning sort of the motion of the plates to really just meaning any sort of surface remodeling that's based on geochemical processes underneath. And so that word is a very loose word for remodeling of the surface due to the underlying geochemical motions, let's say. Yes, here we go. So, if we look at the two things together, we don't really know whether Venus has a core on the inside, which is interesting. They're going to do some more of these seismic tests. So remember, when we figured out that we had our own core, it was essentially done by looking at the reflection of earthquake, right? Earthquake waves, as the waves of compression travel throughout, they actually are scattered just like any other wave by different densities of material. Really different stiffnesses. Stiffness plays more into it than density. But say that a solid core is going to be stiffer, right? And stiffer materials host faster waves, and so they're going to bend in a characteristic way. And so the hope is that by revisiting the place with some hopefully more durable spacecraft in the next 10 years or so, that we'll be able to do some of these seismic studies and actually make sense of the interior a bit more. It's really anyone's guess. I want to finish up with one more idea to complement this lack of magnetic field idea, and this was something I hinted at the beginning of class today. So, you mentioned the spinning. I think that's a really, really, really interesting point, and I think it probably does contribute to it. But there's something that was discovered in the last couple of years, too, regarding our own magnetic field, which is quite fascinating. So the classic models that we have of the Earth and its formation, let's say there's this story that the thing is 4 billion years old or so, indicates that it has to have cooled by something like 3,000 degrees Celsius over the past four-ish billions of years ago. The problem is that the interior of the Earth doesn't seem to have actually cooled that much. It's actually quite warm below our feet. There's even geochemical energy that can be, some people build this into their homes where they're actually able to heat their homes by tapping into some of these thermal processes underground. We have hot springs here, for instance, which are very much indicative of the heat that's flowing beneath our feet. So this group of scientists, I'm sorry that I didn't reference them here, they proposed this idea that it's actually our moon that's responsible for keeping that heat beneath our feet. Because as the moon is swinging around us, it's dragging all of that material under our feet in this nice motion that gets it swirling, and all of that swirling leads to friction. And of course, friction, in some sense, organized friction leads to electricity. And so those currents and the sustainability of our magnetic field and the sustainability of the heat, the interior heat of the planet may have very much to do with our moon itself. And of course, Venus does not have a moon. So maybe that's part of the story of why Venus has had such a nasty life compared to us, or at least doesn't have a magnetic field to protect it from the devastating effects of the sun and the solar wind. All right, next time we will start talking about Mars. And yeah, hope I gave you guys something to think about. Have a great weekend, and we'll do our one more week before the break next time.